maximum ice cream bars problem of Leetcode. It is a daily challenge problem, and the problem is 1833. Okay, so let's see. There is a boy who visits an ice cream store, and he finds that there are n ice creams bar in that store. Okay, so like n here, n is 1 2 3 4 5. So this store has 5 ice creams, and the boy has some limited amount of coins. Okay, so the boy has 7 coins, for example, and what he want to do, he want to spend these coins to buy at the maximum number of ice creams possible. Okay, he wants to buy the maximum number of ice creams that he could buy in that store, okay, with the coins that he have. So let's see what we can do. Let's imagine these are the ice creams that there are in the store. Okay, each ice cream has some cost. Okay, maybe one, maybe two, then one, then three, something like this. Okay, and he wants to buy the ice cream, so, and he has some coins. Okay, he has some coins. Okay, maybe four. Okay, and he wants to buy the ice cream. So what we can do is like we can find all the combinations of the ice cream possible. Okay, that can be that he can buy. Okay, and for example, maybe he can buy first ice cream, or maybe the second ice cream, third ice cream, or the fourth ice cream, or maybe the first and second ice cream, or maybe the first and third ice cream, first and fourth ice cream. Okay, or maybe the first, second, and third ice cream, and so on. Okay, there are a lot of possibilities. So the number of possibilities that are there is like here we have a choice, like whether we want to buy will whether we will buy this ice cream or not. So similarly for this and for this. Okay, so there are two possibilities here, there are two possibilities here, there are two possibilities here, there are two possibilities here. So total possibilities is 2 to the power n. Okay, when we have found all the possibilities, okay, for each possibility, what we can do, we can see, we can keep track of the count, we can keep track of the maximum number of ice creams. Okay, numbers of ice cream that we included in that combination, and we can then check if it is feasible for that boy to buy those ice creams, because he has limited supply of money, right? He does not have infinite supply of money, he cannot buy all the ice creams that he want. So the time complexity of this problem is 2 to the power n, and it will exceed the time limit for our problem. Okay, so let's think. So this won't solve, right? This won't help us. So what can we do? We If we think about the problem, it's like we will go to a store, and we don't have any preference to the ice cream. Just our preference is that we want to buy the maximum number of ice cream. So for that, what should we do? We should ideally choose the cheapest ice creams, right? We should buy the cheapest ice cream. So for that, what we can do, we can sort this. We can sort the ice creams in descending order, in ascending order, sorry, in ascending order. Okay, and what we can do is like we can buy this ice cream, and then we can buy this ice cream, and we can buy this ice cream until our money supply is exhausted. Okay, we have some money supply, and until that is exhausted, we buy the ice creams, and we return the count of the ice creams that we bought. Okay, so let's try to solve this problem. So first of all, we need to sort the costs. Okay, sort the cost array in ascending order. For that, arrays dot sort costs. Okay, and one more thing, uh, like, did I talk about the space complexity and the time complexity of this approach? No, actually I didn't. So we are sorting. Okay, we are sorting here, and so for that, the time complexity is O of n log n. Okay, n log n. Okay, n log n, because and then we are traversing also. We are also traversing. First we are sorting, and then we are traversing to find like till where can we reach. So for that is n log n plus n, but since this is the bottleneck, we will say that the time complexity is n log n. We are not using any extra space. Maybe we will use a sum variable just to keep track of the sum that we have till a current point, the cost that we have already exhausted in buying the ice creams. So for that, so the space complexity would be O of 1, right? O of 1. Now let's continue again. So what we did, we sorted the costs of ice cream. Okay, so now let's put the total. Okay, this is the total equal to 0. We will store here the coins exhausted. Okay, exhausted coins we will keep here. Integer count equal to 0. Here we will keep the count of ice cream bought. Okay, so now what we can do is we can just start traversing the array for integer I equal to 0, I is less than cost dot length plus plus. Okay, so if we find that costs of I plus the current ice cream cost plus the total cost that we've already exhausted, if it is greater than coins that we have, what we should do? We should break, right? Break. Else what should we do? We should just like keep on moving. So we will increase our cost, we will increase our total plus equal to costs of I, and we will increase the count by 1. Okay, and when we are done, we are out of this array, we can just return count. Okay, count is the total number of ice creams that we have bought. So let's see if this solution works. Yes, now let's submit and see. Yes, so it is working. Thank you.